Today's lesson is going to be on Reveal, Algebra 2, Module 1, Lesson 6. Special functions. We're going to focus just on piecewise functions for this video. So what is a piecewise function? Think of it as being a combination of functions in one, all in one. All right, or in this particular example, so it's going to look like this. It's going to have f of x equals and then bracket. And so this is like two different functions on one graph. Right? And so x plus 1 is graphed here, and 1/3 x plus 10/3 is graphed there. Not correctly, but we're not going to focus on that. And then it's going to have these constraints to the domain. So only if x is less than -1. So it only exists to the left. And only if x is greater than -1. So it only exists to the right. Let's dive into the examples. I think it'll start to make more sense. And so I'm going to graph the top one, x minus 3, first. And then I'll talk about 2x. And so x minus 3. And so really that is just saying y equals x minus 3. And so I know my m is 1/1 and my b is -3. And so I'm going to start here at -3. I'm going to go up 1/1, up 1/1, up 1/1, or down 1, back 1, down 1, back 1. And I want to draw it in nice and light. And then I'm going to address this constraint. X is less than or equal to 1. Well, x is 1 right here. And so I go down to the graph right here. And I go, okay, that's where it hits 1. It's equal to, less than or equal to, and so I remember that's a closed circle. I can't make circles very well, so I'm just going to make a blob here. And then it says x is less than or equal to. Less than points to the left and it goes to the left. And so I'm going to just make sure I know that. And then I want to go to the one I had to the right. It doesn't include the stuff to the right of that, so I erase it off. And so I have that part of that line. And then I want to do the same basic kind of thing here for the next one, y equals 2x. And so my m is 2/1 and my b is 0. And so I would start that graph at 0 and go up 2/1, up 2/1, up 2/1, and then I'm going to draw it in nice and lightly, best I can. All right. Now, again, I have to look at this constraint. X is greater than 1. Well, x is 1 right here, so I go up till it hits the line. That's where x is 1 at. Now, it doesn't include it this time, and so I'm going to draw an open circle there. And then I'm going to say greater than goes to the right, so I'm going to draw this into the right, and then I'm going to go erase the stuff that's to the left. And so that is now my piecewise function graph. Give it a try here. Do you think it's A, B, C, or D? All right, let's start discussing this a little bit. 1/2 x minus 2. So if I was at -2 and I went down 1/2, down 1/2, all right, I would have this. And so all of them have some little bit of that. Now it says x is less than -2. So I go back to -2, down, and it should be open circle. And that's not, so I know right now it can't be A. Back 2, down, open circle, yes. Back 2, down, open circle, yes. Back 2, down, open circle, yes. But it's less than, it should only be from the open circle left. This part is the part where I should erase. And so I know it can't be D. Now, is this middle part here, it says 3 from -2 to +2. And so I think it should go across here. And I would argue that this one here should have a closed circle right there. right? And then if it was me, I would do the 3 part would be like this, and then for the downward part, I would put an open circle. So that way I kind of draw both parts there. But I think B is the best answer for this problem, even though I would argue that maybe we should have a little bit more going on right here in this corner, this elbow. Right? So the football coach is ordering new jerseys for the new season. This is the case that we have piecewise functions in real life all the time. Right? So the manufacturer charges $88 for each jersey when 5 or fewer are ordered, $75 each for an order of 6 to 11, $65 each for an order of 12 to 29, and $56 each for 30 or more jerseys. And so what I have to do here is write a piecewise defined function and then evaluate the function. The evaluate we'll do on a different slide. We'll answer questions about it. All right, but that's what I need to do to answer this question. So that's really what it's asking me to do. And so to do that, I have f of x equals, and I'm going to have something here. Now, first, what the heck is x? For this problem, x is the number of jerseys. And so I either have 88x or 75x or 65x or 56x. And now they all are going to be constrained. If I buy 1 jersey to 5 jerseys, now I can't buy half a jersey. I'm still going to write it from 0 to 5, and it includes 5, because I want to have more examples where I can buy like a 0.1 of something or a quarter pound of this or a half pound of that. And so I want to get used to writing it this way. If you wrote this one like this, would that be wrong? No, that would fit this situation just fine because I have to buy whole jerseys. But I'm just trying to get you used to the fact that we're going to have more where you can be a 0.1 or can be a 0.2. And so anything more than 5 would go on to the next one. I guess more than 5 here has to be a 6th jersey. But anything more than 5, I can buy 5.1 of it, then that would be more than 5. Up to 11. And then anything more than 11, up to and including 29. And then the last one is just everything bigger than 29. And so you got to get used to, and that's the tricky part, is how you should write, rather, the constraints to the domain. And so we have that same table here, and now we got to evaluate it. And so where does 11 jerseys fit? There's 11 here and 11 here. So which one do I use? Well, this one has the or equal to, so it's included here. And so I'm going to do 75x, and x is 11. Type that into a calculator and get $825. Where does 25 fit? 25 is between 11 and 29, so it goes into 65x. And so 65 times x, which is 25 jerseys. Type that into a calculator and get 1625, 1,625. And then where does 29 fit? 29 is again here and here. And so 29 is going to be included in up there in 65x. So I do 65 times 29. The coach probably could have saved himself some money if he bought 30 instead of 29, but 29 it is. And so $1,885 or $1,885. Last is a certain type of function called a step function. It's a piecewise function that's segmented and it looks like it's gone up, or it could be looking like it's going down in steps. Right? An example of this is like mailing things. So they're going to charge for up to 1 ounce. They're going to charge 47 cents. And so 47 cents. They're going to charge 68 cents for up to 2 ounces. Up to 3 ounces is 89 cents. And then $1.10, but that only goes up to 3.54, and then they're going to make you like buy more packaging. So those are the rates for stamps, or for the post office, rather, for first class letters. And so again, let's put those in here. That'd be 47. That would be 68. That would be 89 and $1.10. And so they already have this one graphed. 47 cents, they've decided was right about there up to 1. So this one's going to go from 1 to 2 at 68 cents. So I'm going to go 68 cents, I'll say is about here. And I'll go all the way out. Drawing straight isn't my specialty. 68 cents, drawing out to there. Or 89 cents. 89 cents, going from 2 out to 3. Or $1.10, going from 3 to just past 3.5. And so it just looks like it's going up in steps. Oh, I don't need that. It just looks like it's going up in steps, and so that's why they call it a step function. Hope that you understood. Give it a try.